Okay, welcome the Yusun to present this one.
Hello everyone, I'm Yusen Zhang from the Penn State University, and today I'm talking about our new work on TACO 2023, which is about the controllable summarization. So, sorry, how to change pages? Okay, I know that. Thanks. So, given a news document which is pretty long, a user may want to have a shorter version which contains the salient information about this news document. And the powerful transformer models, such as GPT, BART, and so on, can generate such summary with very easy data set, or I mean, it's not hard for transformer to do such task and generate the summary like this. However, the users may have some other requirements, additional requirements, or they want to customize their summaries. For instance, they want to have a longer summary. And it's still doable with some tricks. The previous work, they split the generic summarization dataset into different splits or buckets. To control the length of the summary, they split the summary into different buckets according to their length and train the model. Then the model has the capability to control the length. So similarly, if we want to control the topic, for example, we want to generate the summary about the blood moon, the model can also generate such summary. However, if we want to write the summary about the blood moon and longer one, so it is not doable on this kind of transformer models because it is not trained on such data set of mixed attribute control. So to sum up, existing works have to craft pseudo datasets by adapting generic summarization benchmarks. And most research focuses on controlling single attribute individually, like length or topic or speakers and so on. To this end, we propose MACSum. It is the first human annotated summarization dataset for controlling mixed attributes. And it contains both news articles and dialogues, like meetings and so on, with human annotated summaries controlled by 5 designed attributes. To be specific, we have 2 attributes to control which content of the source to summary. So first is topic. It indicates certain content of the source that users are particularly interested in. We provide multiple keywords such as remote control of financial information or blood moon, blood moon as mentioned before. And the second attribute is speaker. It indicates certain speakers in a dialogue whose content is preferred by the users. And we also have 3 attributes that control the properties of the summaries. So the first one is length. Obviously, it indicates the length of the in the number of words in a summary. And we have 3 levels of value, like short summary, normal, and long summary, etc. And for extractiveness, it describes the proportion of the summary extracted from the source text. And it also has 3 values, like normal, high, and full extractiveness. And for specificity, it means how many details or descriptive contents we need to include in a summary. And it has normal and high. So comparing with the previous dataset, our dataset supports both dialogue and document, and we call them MACDial and MACDoc separately. And it is human annotated with multiple output, which means for a single input source, like single news document with different set of control attributes, the output or the summary can be different, which is a novel idea. And we also support mixed attributes, and there are 5 attributes in total. So to measure the level of control, we also proposed 2 automatic metrics. The first one is called control error rate, or CER. It measures the distance between the generated and the gold summary in terms of their degrees of control using attribute metric functions. So the definition is, for a control attribute R and its attribute metric function fr, given a predicted summary y hat and goal summary y, the CER is defined as the absolute value of fry hat minus fry over fry plus epsilon, where epsilon is just a small value to avoid dividing by 0. Similarly, we define control correlation. It measures the distribution of attribute metric functions among generated summary with different attribute values. So given to generated summary y1 hat and y2 hat, it is the attribute metric function difference between them and over the distance between v1 and v2. So for example, if we were measuring length, v1 is short and v2 is long, the distance between them is -2. And we hope the distance between these two terms and the two generated summaries are similar. Yeah, these two metrics to measure the controllability. So here is the definition of attribute metric functions. So basically, it maps the summaries to a real number to measure the degree of control. So for topic, it is the proportion of topic keywords shown in the summary. And for speaker, it is the number of tokens spoken by the selected speakers divided by the total number of tokens in a summary. And for the length, it is pretty simple. It's just the number of tokens in a summary. And for extractiveness, it is the average of root 2 precision, root 3 precision of the generated summary against the input. And the last one is specificity. It is the empirical formula, which is the weighted sum of verbs, tokens, nouns, numerical tokens, and number of sentences in the sum. And to evaluate or establish the baseline for this model, for this MACSum dataset, we proposed two variations of the model. The first one is hard prompt, which changes the input format. It just simply uses the description of control attribute as hard prompt, which is prepended to the input source. Yes, and the second is soft prefix, which changes the structure of language models. So it prepends external trainable parameters to both encoder and decoder to control the summarization model. So actually, this is similar to the prefix tuning idea. And according to that two variations or changes, we combine them together, and there are 4 combinations in total. The first combination, of course, is vanilla BERT, which there's no variation. And the second one is hard prompt, and the structure remains the same, and we just prepend all the control prompt to the source text, and it's the second variation. And the third one is SP, or soft prefix. It is the same input tab with the prefix tuning structure as the language model structure. And the last one is the combination of these two models, which use the prefix tuning structure and the modified input type. Yeah, so there are 4 models in total. And here is the result on MACSum. As can be seen in this table, HP yields the best performance among the 4 different variations. And we evaluated it in 3 metrics, including CER and CC, which are 2 automatic metrics we proposed. And the quality we directly use the root score. Yeah, and HP yields the best performance on all 3 matrices. And this is the MACSum dataset. Similarly, HP yields the best performance, and expect that quality is a little bit lower than the baseline. And to better evaluate it, we also conduct human evaluation. We randomly pick 30 examples from each dataset, evaluate on 3 models. And for each attribute, we directly annotate 0 if it's not controlled. Otherwise, we annotate 1. It means, okay, it's controlled. So here is the result. And the result shows that a human evaluation is consistent with autometrics, like as shown in this table. HP yields the best performance as well. And additionally, we annotate the gold summary because gold summary is also proposed by us. So we want to evaluate the quality of the gold summary. So, and as can be seen, gold also show the quality of the annotation because it's pretty high and the kappa is pretty high. Yeah. We also conduct analysis on difficulty of attribute values. So the x-axis shows the control attribute and its value. For instance, S in length is the CR of all the length short samples. So now this figure shows MACS'ALL and MACDOC has different distribution over the value of control attributes. And here is the dependency of the attributes. The results shows for MACDOC, length has the most impact on other attributes, while specificity has least. And for MACS'ALL, extractiveness has most impact, while specific has least as well. Yeah, so they have different distribution, different dependency of attributes. I think it's because of the dialogue and news document has different structures. So we also find some very interesting cases, and here we summarize them into 3 categories. The first one is called topic defocus. So the generated summary includes the keywords, but the content is not closely related to the keyword. And the gold summary does not contain the keyword, but it is quite related. So this example shows the topic of education. So the gold summary does not contain this word education. However, the quality is higher than the generated summary. And generated summary contains the education. However, it's just a sad topic or it's a trivial idea in the generated summary. So it's pretty interesting. And the second is length against specificity. So long summaries contain more tokens and inevitably invite more specific information. On the contrary, short summary only describe core events using a few words and are naturally biased toward low specificity. Yeah, so it's kind of like a contradiction between these 2 control attributes. And extractiveness against readability. So when the extractiveness is full, the model generated summaries are tropey and unnatural, in particularly for dialogues. So because you can only extract contents from the source text, it's obvious that it could be more choppy because you cannot get a fluent or readable sentence directly copied from the source text. And so we propose MACSum. It is a high-quality human annotated benchmark for mixed attribute controllable summarization. And we explore the hard prompt and soft prefix model to show this is a challenging task as a large gap. And future work can design more effective models and explore mixed attribute control on other generation tasks. And welcome to visit our paper and code. And thank you for listening.
Okay, we have 2 questions to ask, so who want to ask the questions? Okay, then thanks again.